So that's the idea behind Pulumi, is that you manage your infrastructure with your, well, with a general purpose programming language. And there are several options of those languages supported. At the moment, this is 4 runtimes, Node.js, so TypeScript, JavaScript, or whatever is transpiled to JavaScript, Python, Go, and probably the most important for tonight is .NET. So any .NET language, C#, F#, VB, also PowerShell. You can from PowerShell call it if you want to. So honestly, Go and .NET are still in preview. We launched them not that long time ago. They are catching up. We'll release them in April, I guess. But they work. They just like many documentation and stuff like that. Another thing that we support many providers, so Azure for sure, but also AWS, GCP, things like DigitalOcean, Cloudflare if you want those, but also things that are not really cloud, something like Kubernetes, OpenStack, or even Postgres, Oracle, New Relic, a lot of monitoring tools. We have maybe 40 providers at the moment. So everything that you can think of as creating resources in there can be made a provider for us. Finally, some code. In this snippet, I create 2 resources in Azure. The first one is resource group and then storage account. This is just C# creating new objects in C#, basically. A new resource group with a name, and then new storage account with some parameters, and one of them is the resource group name. So just by using variable resource group here, that tool is sort of smart enough to figure out the dependency between them. So it will know that it has to deploy resource group first and then storage account, even if you manage somehow to place them in different functions or classes or whatnot. And the most important thing to understand here that this is still desired state. So this is different from C# SDK for Azure. When you run this code, basically nothing happens automatically. It just builds that graph of resources that you want to build. And you always describe your final state. Doesn't matter what's your current state. You describe your target state in this file, and then there is a sort of a pipeline of tools that you need to use to deploy this. This is shown on the diagram. A couple components in Pulumi. First, at the bottom there is a language host that knows how. That depends on the runtime first. For .NET, it knows how to compile and run your .NET applications. So it makes .NET build. If it builds, it makes .NET run. And the result of that .NET run is a definition of graph, so a serialized graph. Then the serialized graph goes to command line tool that I'm going to show in just a minute. And that's the smart guy, so it knows how to compare that graph with the previously deployed graph, previous state, and then figure out the difference. If you run it for the first time, the previous state is empty, so it will say, okay, I need to create 2 resources in order. And then it will call Azure provider, please make me a resource group, and then make me a storage account. If it's a second deployment and maybe we change some properties on storage account, it will not touch resource group, but will only change the storage account. And providers are sort of dumb things. They know how to create, update, and delete resources. They don't know anything about lifecycle or dependencies and so on. So just to show how this works, a quick demo. Yes. So I have a sample project open. In this case, that's AWS deploying static website to AWS. But it would be the same with Azure. It's just a C# project. So I have my SDK style CS proj file. It compiles for .NET Core 3.1. And then it have 2 NuGet dependencies, one the core library of ours, and then AWS specific one. And then I can also reference whatever I want here, but in this case I need a NuGet package called myMtypes. Doesn't matter. Then I have 2 C# files. Program.cs, very simple, a main method, so it's a console application. And then all it does, it calls Pulumi deployment run with a generic parameter. And in this case, it's very simple, but you could do anything you want here, like load configuration, do your DI, I don't know, or call a web service, doesn't matter, it's your code. And then finally, all the stuff is here in this class. The class is called static website. It's derived from stack. Stack is our container for one deployment. So stack contains all your resources. That's like virtual resource. All dependent resources are deployed as part of one stack. And then the class has constructor. That's where we create all the resources. The first one is S3 bucket. That's like storage account, storage container in Azure. I just give it a name, and then I say that I want it to be a website. And then on my disk, I have a folder called www.root. And then because it's just C#, I can sort of iterate through the files. And I want to deploy every file to my static website. I currently have 2. So my for each loop will run twice. It will find 2 files. It extracts the name, gets the MIME type, and then it creates a bucket object for every file. So it's just C# code. I can do whatever I want here. I'm not really limited. And because I don't know the URL of that website in advance, it's going to be provided by AWS as a response. So I need to return data from my program, and that's how I do it. I declare a property with an output attribute, and I assign a value from like bucket website endpoint, which would contain the value eventually to that property. So now I cannot run it just from Visual Studio because that would just create the graph, not the resources themselves. To create the resources, I need the second component, the command line tool. So I have it installed on my PC. I just need to say I'm in that folder where my project is. I say pull me up, which should run my, well, first compile my program in case I changed it. And then run it, and then the result is gonna be the definition of the graph of the resources. Well, the tree in this case. It shows it's gonna create 4 resources. The top one is virtual. It has namespace Pulumi, so it doesn't create anything in AWS. It's just a container. And then AWS is free bucket object for about HTML and for index HTML. And then that's just a preview, so nothing happened yet. If I'm happy with this, I can say yes. And then it runs the program again. And while running it, it will start creating the resources at the same time actually in AWS. So it will show you the progress. It knows that bucket has to be created first. And then when bucket is created, it does in parallel 2 files. And the result is that I get a URL back. That's my endpoint property. And then I can click that URL and hopefully, yes, get the index.html page. So now to make it a bit more interesting, let's change something in the program. First, I can maybe add another file. Where is my file? Or just like rename it. What am I doing? Okay, I'll use keyboard. Say I want company HTML instead of about HTML. And then in the code, I don't know. Yeah, I will not change anything for now, but you can see that it's just C# code. So if I start typing something, I get IntelliSense. If I mistype something, it should complain at me when I start typing. So yeah, something like that. It works with any IDE and so on and so forth. So if I go back, I can run it again. You remember I renamed the file. So it runs again. It knows the previous state of the deployment, and it will compare the previous state with my new target state. So it's running the preview, and then you can see that it figured that the old file is gone, the new one is about to be created. If I'm happy with this, I can also see like the details of those. What are the properties? It's going to be HTML file with this name in this bucket. If I'm happy with this, I can say yes again, and then it will run and deploy my changes again. Bring it to the new target state. It creates a file, delete the file. Finally, if it was my just development machine, I played with this, I can do another command, Pulumi destroy. Very handy in AWS to clean up resources. So what it does, it just compares the empty target state with current state and figures out all the steps to delete everything. So I can just clean up so that I wouldn't forget after the meetup. All the objects. Yes, so that's the workflow. Any questions about the workflow? Yes. I will have a slide about this. I will show you. Yes. Sorry for interrupting. Yes. Okay. Let's move on, and then more questions can come later. So what else can I do with this? Let's take an example of my favorite Azure functions. So as I mentioned, if I want to deploy just hello world HTTP Azure function, I have to deploy 5 Azure resources. Function plan, doesn't matter, storage objects. And then the 6th one is a resource group. But what if I don't want to care about them every time when I need a new Azure function? So in Pulumi, we have a concept of component resources where you can combine several resources as sort of one logical resource, like a class that you would create in your typical program. And then the component resource can encapsulate as many complexity as you want inside, and then provide a simple sort of public interface to their users. In this case of function apps, I created a sample component called archive function app, as shown here. So that's the usage of that component. And it's very simple, just like 4 lines of code. You declare a name, and then you pass the resource group, where to put it, and then a path on your local disk. And then what it does, it reads the path, zips it up, creates storage account, storage container, puts zip file there, creates consumption plan, creates function app, links everything together, and that happens inside the component. So when I run this simple program, I will get a preview like that. I will see that I have a stack, as we already know. Then I have a component, so another level on the tree. And that component has 5 other resources inside of it. So I can do this work once and then reuse that class again and again every time I need a new Azure function. Also, I can make it as flexible as I want. So let's say, in this case, I deployed a .NET function, Azure function. If I want to deploy a JavaScript Azure function, well, I change the folder, obviously, but also I can pass additional parameter runtime node, and that would configure the Azure function app for this runtime with app settings and whatnot. So by default, it assumed .NET, but if I pass it explicitly, it would understand that now I want different runtime and configure it differently. A more complicated case, if I want to deploy Python Azure functions, they can only run on Linux, and the previous ones were Windows by default. Python doesn't run on Windows, I don't know why. Well, for Azure functions. So you have to deploy it on Linux app service plan. And also on a separate resource group, not the same one as Windows. So I have to create a resource group. I have to create a Linux consumption plan. So it says dynamic Linux. And then I still can use my component, but I just pass an extra parameter saying plan, Linux plan. And you can imagine that this component has like an if statement there. If you pass something there explicitly, don't create a new one. But if nothing was passed, create a new consumption plan on Windows by default. So I can make it as flexible as I want. The component can be quite complicated or pretty simple, but the goal is to make the usage of that component simple for myself or for others. A slightly more complicated scenario. Let's say I work in an e-commerce company where we do something like Amazon, competing with Amazon. And we have customers all over the world, like in America, Asia, Europe. And we might want to make, of course, experience as good as possible. So we deploy our application as close to our target customers as possible. So in this case, maybe I can use Azure Cosmos DB. Is great for replication data between regions and very fast and so on and so forth. But if I want to use my function app, it's always deployed to just one region. So I have to deploy n copies, 5 copies maybe of function app to every target region so that it's close to my customers. And then deploy something like a traffic manager of Azure Front Door as load balancer, sort of, which knows how to redirect the customer to the nearest one, and then configure function app to talk to the proper replica of Cosmos DB. So you can see, like, I can easily get just 5-fold more resources because I want to do that. And maybe we do something like microservices. I work on a product page, and my colleague works on a shopping cart, maybe. And they sort of have the same challenges of distributing their infrastructure, but maybe they don't use function apps. They use, say, container instances with Docker container registry. And they still have to deploy it 5 times, but their infrastructure is quite different, but still sort of the same shape. And maybe a third team is working on pricing engine. They use some old Java code, and they can only run on virtual machines. So they have to deploy in every region a separate VNet, subnet, load balancer, public IP, VM scale set, auto scaling rules, blah, 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 and copy it 5 times. So we can set down together all our teams, and we identify our similarities and our difference, and then we say we create a component which is, let's say, called Cosmos app, that can create all the common structure with multiple regions and load balancing and Cosmos and whatnot, but then make the compute component pluggable so that everybody would be able to put their own compute into this gray box, but still use the component. So let's say the component is done, and then my usage code becomes simple again. So I create a new Cosmos app, I pass arguments, resource group, a list of locations where I want to deploy it, 3, 5, doesn't matter. And then the last parameter, because it's C# and not a YAML or something, I can just use factories, callbacks, something like that, dynamically provision my placeholder. In this case, the callback will be called once per every region while the component is creating resources. So it will be called 3 times in this case. And then every callback just creates one function app, as I showed before. It connects to Cosmos DB, uses those input parameters from the callback, but it's very simple, and then it returns the endpoint of Azure Functions so that load balancer could hook it up properly. And then another team would create container instances, another team would create VMs, but they just create one callback function and reuse the component. So component could become a shared library, a NuGet package. We put it into our company NuGet repository, or we share it with everyone in the world on GitHub, or I don't know. We start versioning, we can use semver, upgrade, and so on and so forth. So all the best practices for software development, but for our infrastructure definitions. So a little bit, I hope you understand the use case now, and like the benefits, a little bit how, more details about how it works in the state. First, we have multiple providers, and we have multiple runtimes. So if we want to support AWS, we have to implement 4 SDKs, maybe tomorrow 5, maybe next year 6. And then for every provider, we have to implement all those SDKs. And so it's like 40 providers times 4 runtimes. Go write 250 SDKs. So we don't do that. We have for every provider one representation of what it is, like one model there. And then for every runtime, we have a code gen which generates from intermediate representation to the target runtime. So all the C# code for Azure or for AWS, it's fully automatically generated from the representation. If you go to GitHub, it's all public. You try to edit something, you see a header in the file. Please don't edit it manually. It's going to be rewritten next time we generate code. So if you want to contribute, you contribute to that intermediate representation, and then it sort of fixes all the SDKs. So what's that representation? Well, we have our internal model, but more importantly, we can plug some other known formats there. The most important one currently is Terraform. So Terraform is a mature tool, open source, has a lot of providers. We can take any provider of Terraform and make it our provider. If you want to use Azure DevOps Terraform provider, I don't know if we already support it or not, but that's like 2 hours of work to plug it into Pulumi. Another case is Open API specs. So for Kubernetes, Kubernetes has great Open API specs. Every time they release a new version, they update specs. We take those specs and generate code from them. And then the day they ship a new version, the same day you have new .NET SDK for Kubernetes. For major cloud providers, it's currently Terraform. So when Terraform releases a new version with a feature that you're waiting for, you will get at the same time Pulumi support. So state management. On my diagram, I had that corner with last deployed step. So what is it? Well, that's a serialized definition of the graph of previously deployed resources, right? It's just a JSON file, basically. It's stored by default on our backend services, service, doesn't matter, SaaS product. Every time you deploy something, the command line tool talks to our backend, stores that state. We can control concurrency so that you don't deploy from multiple places at the same time. You can control permissions, so on and so forth. If you happen to not want to send us your state files, you can opt out from this and store it yourself wherever you want. You can store it on your local disk, just a JSON file. You can typical scenario storing it in something like S3 bucket or Azure Storage. But then if you screw up and it disappears, you kind of lost all your state. Bad luck. That's your responsibility now. Does that answer your question? Yeah, good. So to reiterate, Pulumi, the product consists of several components. The most important ones are the command line interface, so the one I typed in the console, providers that talk to actual clouds, and both of them are open source. You can see all on GitHub. You can create issues. You can create pull requests. Please do. We accept everything. Well, everything that makes sense. And they are both written in Go. So that's maybe a bit harder for this audience. Also, they are free for any use, for your personal use, for your company, your enterprise. That's free. Take it, do whatever you want. And the third component is the Sas Back-End, where the state is stored. It's optional. You can opt out of it, but it's not open source. It also provides sort of like GitHub experience for your infrastructure. You can see history of your deployments, who did what, configure permissions, do some policies, audit formal, and that kind of things. Some visualizations about your resources, dependencies. You can click to your resources in Azure, and so on. But that's not open source, and it's free for personal use, but it's not free for companies, so for teams. So that's how we make money, basically. But that's again, it's optional. We want you to use the two left parts for sure, and if you find value in this, then you pay us money. If you don't, you don't pay. For authentication, we never get any credentials of yours, but your credentials have to be configured on the machine where the CLI runs. So they never leave that machine and go to like our backend service. That we don't need that. You usually, if it's your development machine, you just type AZ login, and then we use that token, AWS configured, and so on. Yes, question. Yes. Yes. Azure, it's not installed by default, so Terraform is installed there by default, but not Pulumi yet. But you can, there is like one command to install it, and then it works in Cloud Shell. Yes, that works. Yes, you just need to run like copy paste from our website one PowerShell command, and then it's installed on that virtual machine, and you can use Cloud Shell. Yes. And if you don't use CLIs, you can configure all the tokens through environment variables, so more for CI/CD scenarios. A typical workflow is that if you are a developer, you are like me, typing commands. You are connected to your dev account. You can screw it up if you want. Doesn't matter. Hopefully, you don't have access to your production. At least not easy access, so that you don't accidentally do some bad stuff. Usually you would commit your code and then all the best practices. It runs through pipeline, maybe run some tests, hopefully. Unit tests, because that's code. I'm going to show that. Integration tests, maybe you create a test environment and so on. When you're happy, you hit a task in your CI/CD pipeline and it runs Pulumi to deploy resources. And that's where your environment variables are configured with proper access tokens. So we have integrations with like major CI/CD, definitely Azure DevOps. It's just a task in the Azure DevOps pipeline. You can add, select some credentials, and then it just works. But in the end, they all call that command line tool behind the scenes, but you don't have to do it manually. Yeah, another topic about Kubernetes. Not many Kubernetes users, but that's also an illustration of what your more complicated scenario in Pulumi can look like. So if you don't know Kubernetes, ignore all the details, but look at the structure. Kubernetes is a complicated thing. So if you want to deploy something to Kubernetes, you have to deploy infrastructure on multiple layers. First, you need something like networking, storage, and permissions configured. Then you need a managed cluster like AKS. Probably use some managed services from the cloud for that, Cosmos or whatnot. And then multiple applications by multiple people get deployed to that Kubernetes cluster. And the good news is that you can manage all those layers from Pulumi and from one program, but I did probably from multiple programs made by multiple people, because those layers are probably deployed in different time by different kind of persona with different credentials. That doesn't change that often, maybe never. That changes more often, but still not that often. And then applications, many people just deploy something to your cluster. So for that, there is also a way to structure your deployments in Pulumi. First, you have your organization, that's your entity. Then you have multiple projects. So a project is something that I wrote for S3. That's one C# project, basically. And the stack is like environment. So production, staging, testing. You can deploy the same project to 5 different stacks, let's say. It doesn't matter how many. And then if you want to structure your deployment as multiple independent deployable units, then you create multiple projects, and each of them can have multiple stacks. And then those stacks can talk to each other. For example, if you create your infrastructure, you export your virtual network details, IPs, and so on from the first program. And the second program gets those details, creates a Kubernetes cluster. It exports kubeconfig, which is like connection string to Kubernetes. And then the third stack would import kubeconfig to connect to the cluster and deploy the application. So they all sort of related to each other, but only through data that pass from one to the other. So a quick demo about this. Another ID somewhere. So I have a sample solution with multiple projects. I guess I'm gonna show another two. The cluster creates all the infrastructure, so networking and Kubernetes cluster. So it has resource group, SSH key, Azure AD, entities, virtual network, subnet, whatnot, and finally Kubernetes cluster. And then when everything is done, it just exports kubeconfig to a property called kubeconfig. Yeah, I define it here. That's an output. And that's what's accessible to other stacks, other projects. And that can be project infra in stack production, for example, or dev. And then a different person writes a different program. They need that connection string, so they can use something called stack reference. They give the name of organization project stack, and then they can say, I require this output, so fail if it doesn't exist, with this name, and it gets a connection string, and then it starts creating Kubernetes objects from there. So that illustrates the structure, and the service deployment is my custom component, just to show you how custom component look. So it's again a class, you derive it from component resource, and then constructor with a given name. That's what you see in CLI when you run it, and then it creates all the infrastructure for the components. Doesn't really matter. If you use Kubernetes, you can there are also components to like import your existing definitions. Say you have app YAML file, you can just define config file app YAML, and that will deploy that YAML file to your cluster, or something like Helm charts. But that's Kubernetes. Back to the slides. So yeah, the title is set F#. Any F# developers here? No? Okay, I only have 2 slides, so that's fine. Basically, to illustrate that any .NET language can use the same SDK. So if you happen to be F# or VB.NET or even PowerShell developer, you can use it instead of C#. So in F#, that would look very familiar, just different syntax, different indentation, but still the same idea. You create accounts and app service plans like that. At some point, we might create some specific wrappers to make it more F#y, more idiomatic for those users, but that at the moment it's like that. Yeah, this slide is not really important. So important questions. Question: how do we make sure that quality is there? Well, at least one concern I hear sometimes from more operations people, I guess, is that if I give my developers all these powerful tools, they're gonna do horrible things. They will shoot themselves in the foot, create something very expensive, or violate everything. Well, first you can do the same with YAML and JSON, like you can do horrible things there as well. But also, because you use, so you still need to use like policies and permissions and so on and so forth. But also because you get full-blown general-purpose programming language, you can do things like unit testing. So instead of running deployment run, this test runs deployment test and then passes that stack. And that doesn't do anything in your production or anywhere. It just returns back the definition of resources that you are about to create. And then that's C# objects, so you can just start querying them. In this case, find the security group, find ingress rules of the security group, and then check if there are any SSH ports open for that security group. So if you want, you don't know what happens inside that stack, but if it has security groups and it has SSH ports open, just fail the test. And that runs in like milliseconds. You can do TDD, whatnot. You can run it independently from any credentials, all the benefits that you use from unit testing. Now, there are some limitations here because those resources are not created yet. So, for example, you cannot evaluate the URL of that static website because there is no static website, there is no URL. You mainly check the shape of input parameters here. So whatever you provide in the stack, you check it in unit testing. One step forward, and this is TypeScript, not .NET, because .NET doesn't work for this yet. This is called policy as code, and again, policy is real code. So you can write sort of the same unit test-ish piece of code, but the difference is that you deploy it to your environment, maybe to our backend or to your CI/CD system, and then this will run every time anybody ever deploys anything to that stacks. So you do it once, maybe that's a different person, like security officer or IT people. You can check maybe costs of resources or maybe check security rules. And then you make it once, deploy it once, and then all the deployments, while they are running, before creating resources, they will evaluate these rules. And if this fails, the deployment is canceled and you get a warning in your backend, and you can take actions, but they were not violated. You can make them less strict, like recommendations instead of mandatory. And then the deployment proceeds, but you get like warning sign. So that's the power of general purpose programming languages in infrastructure. You can approach it from different perspectives. So to wrap it up, yes. First point, if you do anything with cloud, please use any sort of infrastructure as code tool. Like pick the one you like. If it's ARM templates, great. If it's Terraform, great. If it's Pulumi, even better. But don't like click in the portal for your production applications. You will regret this sooner than later. Then what I also mentioned already, over time we go from bigger components like physical machines to smaller components, virtual machines, containers, serverless functions, and we get more and more of them. So they are harder and harder to manage. So we need better and better tools. And then those tools get created, we start using them, and then we tend to create even smaller components and more complex systems because we can now automate them. So I think this spiral sort of will continue for some time, and probably the tools that we're gonna use in 5 years are gonna be different from the current ones. So it's, for me, it's just an exciting space to watch and like be always in touch with. And finally, why I think that real code is the future for infrastructure as code. It's developer friendly. Developers now start doing application infrastructure, and then they want to use their known skills and tools for that. But also operations people get more productive with things like Python support. You can use conditionals, loops out of the box, nothing special to support that. And the biggest one to me is that you can create abstractions that make sense to you or to broader community, and then reuse them again and again instead of just copy pasting or something like that. Somebody at AWS said that we move from infrastructure as code to architecture as code, and the point is that when you draw a high-level diagram of your system, like squares and arrows, and then you go to the code to define that, you start doing absolutely different things. Like you start defining resources on the lower level, much more of them, and so on and so forth. And now with code, you could define a component for every square block and sort of keep it in sync with your architecture diagrams. And your code structure would reflect like more or less one-on-one to how you think about your systems instead of those very nitty-gritty details on the top level. So a minute of advertising. We have a workshop in Amsterdam. Sorry, I'm from Holland, so in Amsterdam on 30 March. If you go for KubeCon, that's like the day before KubeCon, and it's not related to KubeCon. But if you go for KubeCon, you can attend that one. It's like 4 hours of practical exercise with Pulumi, probably focused on Kubernetes. And then if you need any links, I made a gist with all the useful links. If you just remember that top link, you'll be able to see my slides, Pulumi website, some sample codes, that workshop in Amsterdam, a Slack that you can join and then ask questions. We have like 2,000 people there, and the whole team is there. And a couple of blog posts. These ones are highlighted because I wanted to show that these are not our blog posts. These are, the first one is on .NET blog, so official .NET blog, saying that you can do Pulumi and .NET. And then the second one is on Azure blog, showing something like Cosmos app that I talked about. So even though we sort of challenge ARM templates as a concept, but Microsoft is very happy to make their potential customers productive and deploy stuff to Azure. So they are happy to support us. That's more important than ARM templates for them. Yes, with this, that's all. Thanks for your patience. If you have questions, you can shoot them now or later.